Hello, everyone, and welcome to today's webcast. Today will be a quick 15-minute informational session, which will be recorded and available on demand. If you have any questions, please submit them at any time in the Q&A box, and we will follow up after today's presentation. Paige, over to you.
Thanks, Amy. Hi, I'm Paige Roberts. I'm the Integrate Product Marketing Manager for SyncSort. That means I kind of cover data integration, data quality, and big data software all kind of as a big thing. And I sort of want to talk a little bit about all of that because what we're going for here with this little short series of webinars is to talk about how to enable machine learning in production. So you're looking at trying to get data pipelines to work at scale. And I mean, the nature of machine learning is it has all of these cool things that it can give your company. It can increase your revenue and reduce churn and cut costs and all these great advantages. But instead of sitting down and writing code to accomplish these goals, you have to have data to train your algorithms in order to accomplish these goals. So the data has become, in many ways, like the new source code. So how do you get your data in a shape where you can, first train your models, and then you can productionize those models so that the company can get the benefit? Now, in many ways, this is a two-person job. I mean, a lot of times there's more than just two, but the main roles there are the data scientist whose focus is really on creating the great models. They need to really be good at algorithms and figuring out ways to evaluate data so that you get the predictions or the recommendations or whatever it is you're trying to accomplish at the end. And you want high accuracy and you want dependability. You want this to work. In order to do that, of course, they have to spend a lot of their time manipulating the data into the right form for the model to consume. Now, that's the least fun part of it for a data scientist. The data scientist wants to really get a better and better model. They want to be able to iterate multiple times. They don't really want to spend 90% of their time tinkering with the data. So anything we can do to help shortcut that and make that go faster is going to be helpful to the data scientist. It also means that the data scientist can iterate more times, and instead of accepting an answer to the problem they're tackling, you want to be able to accept the best answer. And in order to do that, you've got to be able to get through the process much more quickly. The other aspect is the data engineer has to step in and say, okay, you've manipulated the data in this way, and then you've used it to train this model, and now this model is good and solid, and I need to feed data into that model exactly the same way as you fed it into your training. So it has to have the exact same changes and steps and tweaks and tinkering along the way, but I have to rebuild this in a much larger scale. I have to rebuild it to work on a 100-node cluster or to work on our big cloud or however you want to do that. Now, that's a challenge in itself. And I believe that one of the things that a data engineer can do to help is to find ways to feed the data to the data scientist like a marketplace, give them a nice, solid place to start with. But then you still got the challenge of getting it into production. And that's what this series is kind of meant to tackle. Now, the previous presentation talked a lot about how do you gather all of this data from all these different places and get it onto your cluster in a way you can work with. Now, the next thing is I've got all my data, but the data is not good. I mean, data just doesn't naturally show up in perfect shape. And if your data is not in good shape, your models are not going to be performing the way they're supposed to be. You need that data to be clean. It needs to be something that your executives can trust. Otherwise, they're just not going to listen to what your predictions are. They're not going to use your recommendations. They're not going to it's not going to get implemented in business, and you're not going to get the benefit. So this is kind of the idea, is that garbage in, garbage out hasn't changed since 1957. Just because we have more data doesn't mean that feeding bad data in is going to give you good answers. It's still a problem, and you still have to tackle it. So this is the next in our 5 big challenges, is data cleansing at scale. So A lot of the data cleansing routines that are out there now are designed for small-scale data. They're designed for data you can fit on a database in a single server. And even then, they're kind of slow. A lot of the processes were designed to spend, you get your data in, and you've got this ETL process that runs, and it takes, a week, and eventually you get your data in your data warehouse, and then you do BI on top of it. That's kind of the old way to do it, and it's too slow. For the machine learning age, we need it faster, and we need it to be able to work at a much higher scale. So the way most people do this is they program from scratch. They start with Java MapReduce, or they write Scala for Spark, and they create their data cleansing workflows in these sophisticated, parallel, large-scale frameworks. The trouble is this requires a lot of skill, and it requires a lot of time. So when I'm trying to make the leap from maybe my data scientists use Python or something else to do their data manipulation, and then they've tried to track it, so now I have to reproduce this at scale in a completely different technology, it's going to be difficult. And once I get it built, the next thing I got to do is tune it, because it's going to be performance is not going to be great. And if I move it from a small test cluster to a large production cluster, or from an on-premise cluster to the cloud or whatever, I'm going to have to retune it over and over and over again. So you can see where the time is just, it's not there. So you've got these common data quality problems that you see in every data set. Anybody who tells you their data is perfect and pristine and doesn't have these data quality problems is either lying to you or to themselves. I've been in this business for 20 years, and I've never seen a data set that was anywhere near as clean as people thought it was. Unless you have the technology to go in there and check it on a regular basis, monitor it, unless you've got in-place data quality, making sure that this is in good shape, it just isn't. It just will not naturally be in perfect shape unless you have something to get it that way. So we have this data. We have it all gathered together, but we've got all of these quality problems. It's like, what is it we're trying to accomplish? We're trying to debug the data, essentially. Just like you used to debug source code, we're now trying to take the bugs out of the data in order to make it work better for our machine learning models. So we want to take this incorrect, incomplete, misformatted data. The more data sets you combine, the more this is going to be compounded. You're going to have multiple copies. We'll talk more about that, because that's a special challenge in itself. When you have data at this scale, trying to match copies, you have to do everything to everything comparisons, and that's a major problem in itself. And you also, a lot of times, you want to enrich the data. You don't just want to clean up problems. You want to actually add to your data. You want to derive fields. You want to enhance with, say, latitude and longitude. It's like, look, I have a street address. Well, if I put latitude and longitude in there, I can do calculations based on location. I can figure out geospatial patterns, things like that. That's an example. I mean, but you may want demographics. You may want to add firmographics, which is information about a company. You want to get the information at the best possible state so that you get the best possible model outcome. And that has to be done in such a way that it's in large scale, it's in production, it's ongoing, it'll keep working for the next 5 years, and it can handle whatever quantity of data you throw at it. And now that kind of is the problem. So what did we do about it? So ThinkSort kind of, we took a couple of different aspects of different software that we had, and we put them together, and we figured out new ways to make this work. So first off, we had Trillium Quality. Trillium Quality is best-of-breed data quality software. It's been on the market for years, decades. It's been top of the Gartner Data Quality Quadrant for more than a decade. And we also took Intelligent Execution, which is a really smart, artificially intelligent dynamic performance optimizer that we use under our big data integration software, so that you can run on MapReduce, on Amazon AMR, Spark, whatever you need to run on, and you don't have to worry about performance because it automatically dynamically optimizes for performance, and you don't have to worry about writing code. So this is a thing to help make things execute at high performance at high scale. And we took that and we combined it with Trillium Quality, which had all of this powerful data cleansing capability. It can match on more than just like individual people. It can actually tell you these 3 people are all at this address and this is a household or a small business. It can give you global address validation, so it can look at an address from anywhere in the world and figure out if it's valid and put it in a standard format and things like that. It can enrich with any data that's missing. Let's say somebody forgot to put their zip code in, something like that. You can totally just get that nice and clean and polished so that your data is beautiful. And now you can do that at scale. And that's really what intelligent execution gives you, is the ability to get your data quality processes working at whatever scale you need them. So if I've got petabytes of data, it doesn't matter. This still works. It'll work at optimum performance for your hardware, regardless of what that hardware is. If I've got a 10-node cluster, if I've got a 100-node cluster, if I'm moving from an on-premise data center to a cloud data center, if I'm going from MapReduce to Spark, it doesn't matter. I don't have to rewrite anything. I just use the point-and-click interface, design my data quality workflow in the same interface that people have been using for design and data quality workflows for decades, that they're comfortable with, that doesn't require any special skill. It requires skills that people already have. And then you just deploy it to Hadoop. You say, okay, I want to run that cluster on Spark. And it runs. And you don't have to redesign it. You don't have to compile it. You don't have to do anything. And this means that your machine learning is going to be top-notch. You're going to get the best results, and you're going to get those at a fairly easy, quick development time. It's going to save you a lot of time getting to production. And once you're in production, that data is going to be available very, very quickly. It's going to be as fast as your cluster can get it to you. And that means a lot of speed of development and getting your data fast in the right format to get the job done. So if you guys want to come back the next couple of weeks, I'm going to talk next week about deduplicating data at scale, matching duplicates, finding them when you've got massive amounts of data. This is a real challenge. And then we're going to talk a little bit about things like tracking lineage and keeping your data fresh, making sure that you've got up-to-date data up to the minute constantly. And those are all challenges that will make your machine learning work better. And I thank you guys for coming, and I'll talk to you next week.